All right, welcome to pre-calculus pretest. We've got a pretest here. It says Curium 242 is used as a power source for satellites. We have a sample of Curium 242. It was found to have 90% of this particular Curium 242. 25 days later, we're going to determine the half-life of the Curium. Okay, so let's go ahead and take a look at what we're going to do here. So let's see. Um, all right. So I got my trusty little thing here. So we're going to say we need, what's our model that we're going to be using for this? And we're going to say Q of t is equal to Q sub 0 e to the kt. And that's like a standard exponential model of what's going on here. So the first thing that we're going to do is we're going to take a look at this. We're going to say, okay, um, we don't know how much was used at the beginning. That's fine. But we do know that 90% of it was there 25 days later. Okay, so we're going to go ahead and use that as a reference here. So what I'm going to do is I'm going to say, okay, after 25 days, right? So we have Q0, E. I don't know what my decay constant is, but I do know that this was 25 days later. And then after 25, how much was left? And I'm going to say 0.90 times the original amount was left. Okay. Now, if you ask the teacher, it's like, okay, how much was starting? I'm like, oh, you don't need to know that. Any amount you type in should be just fine. So if you want to type in 100, because we're dealing with percents, you could say the original amount with percent, and then we're going to have 90 left over. Okay, and then we can just go through and start our deal here. We're going to solve for k. So the first thing I'm going to do is divide both sides by q0, divide both sides by q0, and I've got 0.90 equals e to the 25k, and we're solving for k. So there's a variable in the exponent position. How do we get it down? We take a natural log of both sides. So I'm going to use the natural log of 0.90 is equal to the natural log of e to the 25k. The whole point of taking this natural log is this 25k comes down in front. So we have natural log of 0.90 equals 25k times the natural log of e. And of course, you remember that the natural log of e is 1. So we're going to go ahead and divide both sides by 25 here, and we'll get k is equal to 1 over 25 times the natural log of 0.90. Or you could say this is the natural log of 0.90 divided by 25. All right. Now, I'm going to go ahead and type this as a k sub c for the curium. We can go ahead and calculate this out, and I'll go ahead and do that. So we'll say, okay, let me get my calculator. I know this is not the same kind of calculator you're allowed to use for your tests, but I'm not going to use anything that's not allowed that you would not have access to. So we're going to say 0.9. It's also the only calculator I have that can display on my desktop. That's why we're sitting here with this. So we're going to say, okay, natural log of 0.9 divided by 25 equals, and we're just going to go ahead and save this for what we need. So it's going to be 0.0042. I would recommend you use 4 significant figures when you're dealing with this because this stuff is incredibly susceptible to round off. So we'll say this is negative 0.00. Double check our answer here, 004214. Okay. So we have 1, 2, 3, 4 significant figures as we do this. Okay. Now we need to know the half-life. So stage 1 is complete. We know the K. Now we have to figure out a time. So now part B, half-life. Okay. The half-life is when half of it is left. Okay. So again, we will start off with our Q of t is equal to the original amount, e to the k. Now this k, I'll put a little c on it so we know which k we're talking about, times our time, and we don't know what time is. All right. So again, the first thing we're going to do is we're going to divide both sides by Q0. Again, we don't know exactly how much is left, but so I jumped the gun a little bit. Let's erase this piece here and then say we're trying to find out half-life. So the half-life is when half of the original is left. Okay, so instead of Q sub t, I'm going to say half of the original sitting over here. Then we'll go ahead and divide both sides by Q sub 0, And what's going to happen is this q sub 0 is going to cancel, this q sub 0 is going to cancel, and we're going to get 1/2 or zero point 0.5 is equal to e to the kc times t, and we're trying to solve for our t. So again, there's a variable in the exponent. We take a natural log. So this is going to be the natural log of 0 0.5 or 1/2 is equal to the natural log of e to the kct. This whole business comes down in front. That's the whole point. So we're going to say we have the natural log of 1/2. 2 to the -1 is a fancy way to write 1/2. Okay. And we're going to say this is equal to kc times t. All right. Now I'm going to do one more trick that I like to do because everybody that I ever watch do half-life problem tends to do this. And we're going to pull this -1 out in front as well. So we're going to say this is a -1 times the natural log of 2 is equal to kc times t. We were solving for t. So what I'm going to do is divide both sides by kc. So this is going to be t is equal to negative natural log 2 divided by, what was that huge number we got from before? Was 0.004214. So this was negative 0.004214. And if I'm not mistaken, there's that number sitting there in my calculator. So what I'm going to do is say I need negative natural log of 2. Now watch this. We're going to divide by what I call the answer. That's simply the last number that I calculated in this calculator. So it saves this whole big number in one variable, a temporary variable called answer. And that's how I'm going to go ahead and type that in. You are welcome to type in 0.0042144 and go for it with that. Okay. And then we end up with t is equal to let's see, we had 164 point, I'll call that 0.5. So 164.5. Now, I want to know 164.5 what? So what was going on with this? The original equation, we used 25 days in order to figure out our decay constant. So this is still going to be in days. So my half-life of curium is going to be this amount in days. If the information had been given to me in years, it would be years. But since it was given to me in days, we're going to go with t is equal to 164.5 days. So we're going to go ahead and say that's our half-life, and very good. And we'll stop there, and I will let you watch the rest of the videos. Thank you for watching, and I will see you in the next video.